Hello, my name is Dave Apsley. I'm an extension forester and a natural resources specialist for Ohio State University Extension, and I also coordinate a day in the woods. Welcome to our second virtual program for Day in the Woods. Today we're going to focus on identifying trees in your woods. And I'm also joined by Stephanie Downs, the Southern District Service Forestry Coordinator. Stephanie, welcome and thank you for being here.
Thank you. Thank you all for joining us.
So today we're going to give you some background information and introduce you to some concepts so that when we go live on June 12th, a week from, it'll be June 12th, the Friday, we're going to go through some keying exercise focusing on this OSU extension bulletin. So we want to introduce you to some key concepts. And then if you decide to join us there with the registration material, you'll get a copy of this publication and some links to some other resources. So Day in the Woods, if you're not familiar with it, is a program that started in 2012. It's centered at the Vinton Furnace State Forest in Vinton County. We do programs from May through November most years. This year, we're actually going to go through December. It's usually the second Friday of the month. And historically, they've been in-person all-day programs focusing on topics. This year, due to COVID, we've had to make some adjustments, and the first two programs have been offered or will be offered virtually. We are hoping to go live on July 10th, but that's yet to be determined. The July 10th program is Trees to Lumber, focusing on how to measure and evaluate the value of trees, logs, and then actually run them through the sawmill and learn how that process works. Again, we don't know for sure if that's going to be live or virtual. In August, we will be at Zaleski State Forest again with two separate programs, one in the morning on mapping and using GPS. In the afternoon, we'll focus on legal issues for woodland owners. September, we're looking at woodland wildlife implications of our changing times, again at the Vinton Furnace State Forest on September 11th. October 9th, we'll be at Hocking College. It's going to be really hands-on, lots of demos on tools and equipment for managing your woodlands and wildlife habitat. In November, we're back to the Vinton Furnace to focus on building and maintaining woodland trails. And finally, in December, we'll wrap up with Winter Tree ID, which will be a great follow-up to what you're going to learn today. Today, we're mostly focusing on leaves. There, we'll focus on buds, twigs, and bark and other things that are available to identify trees with. I'd also like to acknowledge all the partners that make A Day in the Woods work. The list is too long to recognize everybody right now, but I would like to point out Hocking College because normally Tree ID for the last several years has been at the college and has worked great because we break into several classrooms and smaller groups when we go out into the field. And then finally, for information about A Day in the Woods, this is the site that you want to go to. We keep our post there current. You'll notice the top post listed here now is actually the videos and the resources that we produced from that first virtual Day in the Woods program back on May 8th. And at that site, you can actually find those video recordings. You can find all the resources that were provided to folks that day. So 8 different programs, 8 different speakers, great opportunity to go learn about woodlands and wildlife. And then finally, I'd like to acknowledge Randy Heiligman and Kathy Smith, who have helped to develop a lot of materials that are in this presentation. We did a lot of Tree ID programs as part of the Woodland Stewards program, and the three of us worked hard to pull together some of this material at that point. And here's the link to the Woodland Stewards program for more educational opportunities. So let's get started. So to start out, when we identify trees, I like to think of it as a process of elimination. If you just go up and look at a tree and try to decide what it is, when we've got hundreds that it could possibly be, it's really difficult. So it's good to just start going down the road and making decision and eliminating parts of the trees. So one of the first way that we can divide all the possible trees into 2 groups is whether they're broadleaf, which broadleaf trees are those trees that are mostly deciduous. There are very few exceptions. Another slang term for broadleaf trees are hardwoods. They're angiosperms, And examples include most of the trees we think about: elm, ash, maple, oak, hickory. The list is almost endless. So here are some examples. They tend to have broad leaves. They tend to be deciduous, which means the leaves fall off at some time, usually after the summer, into the fall, and maybe even into early winter. Here's an example of one. It's called cucumber magnolia. They're angiosperms, which means basically that their fruit is produced in an ovary. So here's an example. This is a hickory, and this is a hickory nut. So all the broadleaf trees produce some kind of fruit in an ovary. They're not going to produce cones or seeds in cones. They're going to typically produce some other kind of fruit. And they're deciduous. Here's an example of a deciduous tree. Leaves are gone, but we can identify this. Most foresters can tell you from this picture what that tree is, and it's kind of hard to believe. But the real key is the fact that this tree has horizontal branches. The branch angle is almost horizontal instead of a more acute angle. This is black gum. So that's one group. And most of the trees in Ohio, especially the native trees in Ohio, fall into that broadleaf category. The other category that trees could fall into are conifers. Conifer translates to cone bearing. Most of these trees are evergreen. And you'll notice when we talk about tree identification, we almost never say always. We say most or usually, because there are a few exceptions of conifers, like bald cypress, that are deciduous. They typically have what we call needles, but they can also have structures that are similar to needles, like scales, awls, which an awl is a tool that is used in leather making. It's a real sharp pointed needle-like structure. We also call them softwoods generally because as a group, the wood tends to be softer than the broadleaves. They're gymnosperms, which they're naked seeds. And examples include pine, spruce, fir, red cedar, and so on. So here's an example of a pine. A key for pines is that pines produce needles in bundles or bunches or groups. So they're not going to be individually attached. They're going to be in groups, usually 2s, 3s, or 5s, and sometimes a combination of 2 and 3. This is actually black or Austrian pine. Here's an example of a conifer that has needles that are individually attached or single. It's the spruce. Firs would also be like this, and some other conifers. This is actually a small blue spruce. Another example of some different shaped needles. This is a native, probably one of the more common native conifers in Ohio. It's distributed in a kind of a strange fashion, but these are all over the Hocking Hills and in small pockets all the way up to Lake Erie. This is eastern hemlock, short little needles in, and basically they're on two sides of the twig. We call that two-ranked. They tend to not be all around the twig, but they tend to be in a flattened plane. That's eastern hemlock. And then this is kind of an oddball. This is eastern red cedar, which is very common in western and southwestern Ohio. It actually has two types of foliage. These are what we call the scale-like needles or foliage. And then the juvenile needles look more like this. And these are those awls, or those sharp-pointed needle-like structures that you'll find on young, typically, or new growth on eastern red cedar. So with that, I'm going to turn it over to Stephanie to pitch in on the presentation.
Yeah, so from here on out, we're going to focus mostly on our broadleaf trees. So looking at what characteristics we can use to help narrow down the choices that your tree can be. So Dave mentioned that it's basically a process of elimination. We have over 100 different species of broadleaf trees and shrubs in Ohio. And walking up to a tree, you need some way to limit your options to figure out what that tree is. One of the first things we usually look at when we look at a tree is its leaf arrangement. So how are the leaves arranged on the stem? There are 3 different options with our trees in Ohio. So our trees can either be alternate, opposite, or whorled. And we have images here of all 3. But with an alternate plant, you only have 1 leaf attached to the stem at any given point. And so you'll have 1 leaf at a given point on the stem, and you have to travel up the stem a ways before you find the second. So they always occur singly on those stems. With our opposite trees, they're always paired. Wherever you find one leaf, you will find another leaf exactly opposite it on the twig. So as you can see in this photo, there's two leaves attached to the stem at that same point. And then the last and least common way that our leaves can be arranged are whorled leaves. With our whorled stems, you actually get three leaves that attach at the same point on a twig. And so they wrap around the twig and will occur three at a time instead of one or two. And we have very few options in Ohio for whorled. We actually only have two different species, and we'll get to that coming up. But if you can limit it to a whorled tree, you have just eliminated all options except two in Ohio. And so that makes it really easy to identify your plants.
So one thing to add, at that point where that leaf attaches is also a bud, and we call that a node. And at the node, that is where the growth would occur. So branching would also have that same pattern. You would have leaves that are either leaves and branches that are alternate, but with the other ones, you'll see that branching pattern as well.
This is an example of an alternate leaf arrangement. This is American beech. So you can see there's leaves and fruit shown here, but you also have the stem in the photo. So building on what Dave said, if you notice, those buds tend to occur singly, alternate of each other, and it almost gives the twig a zigzag-like appearance. And so the new growth of that tree is growing one at a time, and it tends to go back and forth as it grows. So you get this zigzag pattern with one leaf attached at any given point, and at the base of where your leaves attached, you will find that bud, which will come in handy later on when we start talking about different leaf types. But these are alternate. So you have each leaf attaching to the twig at a different point along the twig. So our next group on there was opposite leaves, and this is one of our maples. And where you see your leaf attached, you will also find a second leaf attached. So at that twig, they come out directly opposite each other. And at every point or every node on that stem, the point where you have a bud and a leaf growing out, there's another paired with it. And when you look at the tree as a whole, your branches are also opposite. And so even in the winter, you can look at one of our maples and tell that it would have opposite leaf arrangement by the pairing of your twigs. And you can see this winter stem here. You also have the key where your buds are opposite each other. Those buds are new growth. Next spring, when those open, they will form new leaves at those points, and those new leaves will be opposite each other.
Okay, and the one on the right is red maple. The one on the left in my notes says sugar maple, but I'm wondering if it might be black maple, which is a very close and very rare cousin.
But then we get down to our whorled trees. And like I said, there's only two species of whorled plants. The one that's shown here is northern Catalpa. This is a commonly planted tree in old farm sites, old homesteads that you can see scattered throughout the state. But if you notice, and it's really hard to tell in the photo with the leaves, but if you notice the twig photo, you can see a leaf scar, which is where a leaf had fallen off of this twig sometime in the past. And you might not be able to see the other scars, but you can see where the bud is swollen or the branch is swollen. That's where your other leaf scars are. So you can see there's one on each side of the leaf scar that you can see, giving you three leaves coming off of this twig at a point. Now, when I say that you only have two options, and they're really easy because you have northern Catalpa, which is a tree, grows in dry sites, and the other whorled arrangement plant that we have is called buttonbush, and it is a wetland shrub. So there is really no way of confusing these two. So if you can get it to whorled, your identification gets really easy.
And that's, of course, with our native stuff. In your landscape, all bets are off, but I'm having a hard time thinking of anything non-native too.
Yeah, I can't. With our broadleaf plants, we look first at opposite, alternate, or whorled. Once we determine that, then we start looking a little bit deeper into our leaves. And so we start looking at what our leaf type is. And we have two common leaf types with our trees. We can have a simple leaf or a compound leaf. And what these indicate are how many leaf blades there are associated with a single leaf. And so a simple leaf only has one leaf blade. There's only one area of leaf associated with each individual leaf. Compared to a compound leaf, where you actually get multiple leaflets or small leaf blades attached to a stalk that all composes one leaf. So we tend to get trees both simple and compound, and that is really essential in eliminating options when you look at your tree identification. So your simple leaf obviously only has one leaf area. So this is a photo of an elm, which has a simple leaf. And if you look at the twig, there's only one leaf attaching at a point, which means that this is an alternate species. But if you follow, basically if you start at your leaf tip and you follow it back to the stem, you're looking for a bud. And as you can see here, there's a really small bud where this leaf attaches to the twig. From the bud out is considered one leaf. This one only has one large leaf area, which means it's a simple leaf. In contrast to that, we also have compound leaves. So multiple leaf areas attached to a single leaf. And this one is a pinnate or pinnately compound leaf, meaning that all of your leaflets are attached to a central stalk, or rachis, it's called, arranged like a feather. So they all attach to the central stem and radiate out. So this, I believe, is one of our ashes. So it has small leaflets that attach to the rachis. And if you start at the tip of the leaf, so your farthest out point that you can get to, and work your way back, you're going to work back, and there are no buds along this central stalk. And so you're not going to hit a bud until you actually get to the stem at the bottom of that leaf. From that bud out constitutes one leaf. And since we have multiple parts, this makes a compound leaf. But we also have another type of compound leaves.
Let me add one quick thing here, and that is a lot of folks get confused with opposite and alternate when they look at how these leaflets are attached to this rachis. So don't pay attention to that when you're determining whether it's opposite or alternate. Pay attention to where this whole leaf attaches to the twig. So almost everything I can think of with the pinnately compound leaf has leaflets that are opposite. What we're looking at when we're looking at opposite versus alternate is where the leaves, the entire leaf, is attached to the twig.
That's a good point. That's a really good point, actually. But then we also have palmately compound leaves. And so the way to think about a palmately compound leaf is to think about the fingers on your hand. So all of your fingers radiate out from a central point of your palm. And that's how your leaflets would be arranged on a palmately compound leaf. So this one photoed here, or pictured here, is a horse chestnut, I believe, multiple leaflets.
It's actually a picture I took down at Zaleski, and it's a yellow buckeye, but it's very unusual to have the extra leaflets. So it's kind of a trick.
So our native buckeyes tend to have 5 leaflets, just like the fingers on your hand. Horse chestnut tends to have 7, but like Dave said, you always have those usually. Not always, because there are always exceptions to the rule.
That's the only always, is that there are always exceptions.
That is true. But then our last way that we can have a compound leaf is called a bipinnately compound leaf or twice pinnately compound. And if you look at this photo, it looks like a nice shrub with a whole bunch of leaves on it. But in reality, there's actually very few leaves on this plant. And so these leaves are twice compound, which means you have your central rachis with leaflets, but your leaflets also have leaflets. And so it's a way to break things up into very fine detail. They tend to be very small leaflets, and you tend to get a whole lot of them. Your twice pinnately compound leaves tend to be very large, so they can be a few feet in length and maybe 1.5 feet, 2 feet wide on some of these, or they can be relatively small. And so this one looks like a devil's walking stick, which is a native plant. Tend to find it again in the Hocking Hills where you find hemlocks. But they have a huge number of leaflets with very few actual leaves. And this is where it gets really tricky to start at the tip of your leaf and work your way back and try to actually find that bud. When you find your bud, you might think you're looking at half the tree itself. But from that point out is only going to be one leaf. And so they can be very complex, very difficult to work through, but they're also really cool leaves when you find them out in the woods. And this is one of those cases where you can see all of your leaflets are oppositely arranged along this leaf, but the plant itself is alternate. And so where you find a bud, you're only going to find one leaf coming off of that, even if it has hundreds of little leaflets that are oppositely arranged.
The other thing to point out too, Stephanie, is there are very few species that have bipinnately compound foliage. There is the devil's walking stick, there's Kentucky coffee tree, which is what this actually is. And then there's honey locust, which is an oddball. It actually has both kinds of leaves. It has pinnately and bipinnately compound. Another thing I like to mention, which is a common sense thing that just didn't dawn on me until probably 5 years ago, but if it's got a leaf that's as big as this Kentucky coffee tree, that's 3 feet by 2 feet wide potentially, then it takes a very big twig. So just as a clue, if it's got a big leaf in the winter, think about how big the twig would have to be. So if you're seeing a big fat twig, it's probably something with a compound leaf, or occasionally it's something with a big simple leaf. But usually a big fat twig means compound leaf in the winter months as well.
Okay, so we have our tree. We're narrowing down our options, right? So we've already narrowed down between broadleaf and conifer. Get to broadleaf, narrow it down to opposite, alternate, or whorl. And once you've narrowed it down from there, there's other key things to look for when you start looking at your leaves to identify your tree. And one of the big ones here are your leaf edges. So we call them the margins. Think about a sheet of paper. You have the margins around the edge of the paper. It's also the same with your leaf. You're going to have a leaf edge or a leaf margin that may have different characteristics. Well, a lot of our plants are going to have smooth, or what we call entire leaves, basically like the edge of your sheet of paper. There's no indications, there's no indentations, no lobing. It's just a completely smooth leaf. You may also have a toothed leaf that has a serrated edge, like a serrated steak knife. And so it's going to have lots of teeth along the edge. It's going to have a rough appearance along that edge, and it's going to be completely different than your smooth leaves. Occasionally, we also get leaves that are doubly serrated. And this is basically you have a leaf that has teeth, and your teeth on that leaf also have teeth. And so you get big teeth that have smaller serrations all along the edges of those. So this is an example of our smooth leaf, and Dave put this one up earlier. This is our cucumber tree or cucumber magnolia. If you look along the edges of that leaf, it might be a little wavy, but there aren't any good teeth or indentations along that edge. And so this would be a smooth or an entire leaf margin. In contrast, we have our American beech again. You notice along the edge of this leaf, there are a lot of well-defined, sharp-pointed teeth or serrations along the edge, but they're single. And so you only have one tooth at a time along the edge. Compared to our last option.
Let me give you a hint too. That beech, American beech, is on a piece of white paper. And sometimes very fine teeth are hard to see. So just a little field tip for you. If you have something white, like your field ID key, like the ones we use, if you have something with a white piece of paper, lay that leaf on a white piece of paper, and sometimes you'll be surprised. There may be some very fine teeth hiding. And that contrast with that paper in the background will really make it easier to see.
The other thing to point out is sometimes that shadow shows it a little bit better. So if you can get it to the sun, yep, the teeth will actually show up a little bit better in the shadow than they do on the leaf itself. But then lastly, we have these doubly serrated leaves. And so this again is our elm. And if you notice, there are really coarse teeth along the edge of this leaf. And then if you look closely at those coarse teeth, they also have smaller teeth on the original teeth. And so you get two levels of serration along the edges. And these tend to be pretty coarse looking. You tend to get more texture on your leaves, not quite as simple as those smooth entire leaves are. All right, so we're going to go back to our leaf arrangement a little bit, and we're going to look at some of the common species that we have in Ohio. So if we start looking at some of these opposite trees, this is your second easiest group when it comes to leaf arrangements. So whorl is obviously your easiest because there's only two options. But our next group, our opposite leaf arrangement, when we think about trees, now this does not include shrubs, so I'm going to throw that out there right away. But if you have an opposite tree, think mad buck. These are your options when you have opposite trees in our native woods in Ohio. So we have maples, ash, dogwood, and buckeyes. So using your acronyms, think Ohio State, Mad Buckeye. So we're going to take a look at each of these groups, because when you get to opposite, it's actually really easy to put them into these groups if you look at key characteristics of your leaves. So our maples, which this is one of our red maples shown here, red maples, or all of our maples with one exception, are going to have simple leaves, one leaf area. And again, there are always exceptions to the rule. So there is one native maple called box elder that actually has an ash-like leaf. But most of our common maples are going to have simple leaves. They're also going to have lobes, so indentations in the leaves that are large, bigger than teeth, and some will and some will not have teeth or serrated edges. But they're always going to be, or almost always, going to be simple leaves that are opposite each other on the twig. They also tend to be smaller leaves, so they're going to have fine branches, support a little bit less weight with your leaf area.
They typically have what we call palmate venation too. So if you look at the veins, these main veins which lead to the tip of the lobes, the veins are like the palm in your hand as well. So that's just a term you might see later as well.
Radiate out from a single point.
Yep.
Then we have our ash species, and our ash species are different from the maple in that they're going to have compound leaves. They're going to have pinnately compound leaves, so your leaflets are arranged along the rachis like a feather. So a long, slender leaf with leaflets arranged along that central stalk. They have larger leaves, so they also have larger twigs. So your twigs tend to be a little bit stouter to hold a little bit more weight. And you can see your twig here. Your buds are also opposite, but they actually have velvety buds. So they have a little bit of texture to them, like antlers in velvet, and look kind of like chocolate brown colored. So you get some different characteristics, but this is your opposite group of species that have pinnately compound leaves. None of our other species, or none of our other groups other than box elder, which is a maple, will have pinnately compound leaves.
And for those of you that are curious, this is actually white ash. It's got a U-shaped leaf scar and a notch on the tip of that rachis, where the rachis is basically the mirror image of the leaf scar. So where the leaf attaches, we call that the base of the rachis, and then this is the leaf scar.
Then we have our dogwoods, and like everything else when it comes to trees, they're almost always opposite. And this one here is a flowering dogwood that has opposite simple leaves. So like our maples, one leaf area per leaf, but these are going to have smooth edges and no lobing. So where our maples are going to have lobes and may or may not have teeth, your dogwoods are always going to be a smooth edge with no lobes and no teeth. There is one exception to the opposite though. We do have an alternate leaf dogwood. At least they took it into consideration and put it in the name that it's not opposite. But just so you know, you can run into a dogwood that has an alternate leaf arrangement. Every other dogwood that we have is going to be opposite though. And all of them are going to have similar leaf shape. And if you notice on these photos, if you look at the veins of the leaf, the veins of a dogwood actually curl. So we call these arcuate veins. They arc like a bow, and they're going to curve towards the tip. So all of them start along that central vein, reach out along the leaf, but then towards the end will curve up towards the tip. And this is pretty characteristic of our dogwood species. But they're always going to have simple leaves with no teeth, no lobes along the edges. And then our last group are our buckeyes. And for our buckeyes, they are palmately compound. And so a completely different leaf type than what we've seen with our other groups, but they tend to have 5 leaflets or 7 leaflets attached to a central stalk like the fingers on your hand. So they're our only opposite group with palmately compound leaves. We have 2 common buckeye species in Ohio. We have yellow buckeye and Ohio buckeye. And the easiest way to tell them apart is with the fruit. So we have both here. This one here is the Ohio buckeye, and it will have warts or bumps or even spines on the husk containing the buckeye fruit, versus your yellow buckeye, which is going to have a smooth husk. There's no real good surface features on the husk of yellow buckeye. They tend to be a little bit larger fruit. A lot of times your yellow buckeye will have more than one buckeye per husk, where your Ohio buckeye tends to be a little bit smaller. It tends to only have one buckeye per husk. Both grow in Ohio. They have different habitats. So Ohio buckeye likes floodplains, yellow buckeye likes your drier sites, and yellow buckeye is more common in southern Ohio, where Ohio is more central and northern. But with all of our opposite groups, you have mad buck. So think about your maples are simple leaves with lobes. Your ash are pinnately compound, so multiple leaflets per leaf arranged like a feather. Dogwoods are simple with no lobing and no teeth, and your buckeyes are palmately compound. So when you have leaves, they're actually pretty easy to separate out.
Yeah, it's easy to get it to those big groupings if you really just pay attention and you start looking at whether they're opposite or alternate. I mean, that really helps. And I can't resist, Stephanie. So what's the other way you tell the buckeyes apart?
So the other way to tell your buckeyes apart that I know of is by using the buds. So if you take the end bud on your twig and you roll it in your fingers, yellow buckeye is round, it will roll easily. Ohio buckeye, you'll have a catch. And there's actually a keel, like the front of a boat. So you get this ridge line that you can actually feel when you roll that bud in your fingers.
So she's avoiding me here because the way that I use is if I actually scratch the twig on both of these buckeyes, a young twig, the Ohio buckeye, and I'm an OSU employee, so I hesitate to say this, but it does stink. If you scratch it, it has a skunk-like odor, and another name for Ohio buckeye is fetid buckeye. So I always have to throw that in just for fun.
I'm Ohio State grad, so I avoid that.
I won't say what we used to say when I went to Purdue about how you identify buckeyes. But so now we're going to jump into that big group of alternate species. And there's one really large group of alternate species or species of trees with alternate leaf arrangement, and that's the oaks. We can't talk about all the species, but the oaks have some characteristics that kind of make them fairly easy to at least determine whether they're an oak or not, and then break that into two different categories. All oaks have a cluster of buds at the end of their twigs. So that is, I think, one we can say all. Well, there might be an individual twig out there without a cluster, but by a cluster of buds, it's just an odd number of buds. They're not uniform in size. It almost looks like a little knuckle sandwich. And they all produce acorns. And there's two really broad groups of oaks. There's the white oak group, and there's the red oak group. The white oak group are the ones that have leaves that have rounded lobes with no bristles on the tip. And we'll show pictures to explain this a little bit later. But essentially on those little lobes, you have no bristles on the tip, where with red oak, you'll have the bristles. The other big difference is acorns in the white oak group mature in one growing season. So you have flowering in the spring, you have pollination, acorns start to form. That white oak group acorn matures in the fall, hits the ground and starts to grow. The actual root starts coming out in the fall. So in like one growing season, you have an acorn that starts as a flower and it matures and starts to grow. And they also have some wood characteristics, not all the white oaks, but they actually have wood characteristics that make white oak less rot resistant and actually make it different in how we can use it. This last fact is what makes white oak really good for making barrels, because they form plugs or tyloses in their xylem or in their wood. So those big vessels that carry water up and down in the trunk of a tree, when they're no longer being used, get plugged. If you didn't use white oak for those barrels, they would leak. In the red oak group, as a contrast, all those leaves have bristle tips. Acorns take 2 full years to mature. So you get pollination in the spring, acorn forms, it stops growing in the fall. The next year it matures and hits the ground, and then it won't germinate till the following spring. So we're actually talking 2 full years for that acorn to go from where it's a flower and you have pollination until it germinates. And those xylem vessels are not plugged, so you have these big open vessels, which if it's exposed to moisture, it actually allows moisture to get into that wood fairly deeply, and they tend to not be as rot resistant. But again, all the oaks typically have clusters of buds at the tip. And if you get really good at this, you can learn different oaks by the characteristics of the twigs and the characteristics of the buds. That's a whole class in itself. It takes a lot of practice to get there. But here's an example of a white oak leaf. Very classic. When folks look at leaves of oaks, this is what most people think about. We've got irregular lobing. You'll have different, what we call sinuses. This is a lobe, and then the gap between them is called a sinuses, and the depth of that can vary, and it can vary a lot on a tree too. If it's in the shade, these tend to not be as deep on the oaks. If it's in the full sun, they tend to have deeper sinuses. So this is an example of a white oak, and this is the species white oak, where in this case, you can see with the shadow, actually, like Stephanie mentions, a little easier to see these bristles or hairs at the tip of the leaves. And this is actually pin oak, which is one of many of our red species of oak in the red oak group. Actually, I think there are almost 30 species of oak that you can find in Ohio. It's well into the 20s. And then realize also that not all oaks have lobing. We have a few. This is the native one that you'll see. I've got a lot on my property. It's actually what we call shingle oak. And if you look at the very tip, there is a bristle. So this puts this oak in the red oak group. It's called shingle oak. From there, it gets even more complicated. There are lots of species out there. Most have alternate leaves. And then at this point, you just got to start looking for other characteristics and what makes that tree unique in that leaf. And I like to show pictures of this one because a lot of people don't think about it, but this is very unique in that its leaf, and even on the trees that have compound leaves, the leaflets almost always come to a single tip. But this is one of the few exceptions where you have a flat top or two tips at the end of the leaf. This is actually tulip tree or yellow poplar or tulip poplar, whatever name you prefer. We've got other trees that have different shaped leaf blades. These are actually eastern cottonwood leaves. And the main reason I throw this out is when you go through that key, it'll ask for different things. And Stephanie's mentioned this term multiple times, but I want to reemphasize it. It's this stem on a single or a simple leaf is called a petiole. If it's a compound leaf, the stem is called a rachis. If it's a simple leaf, it's a petiole. And in this group of trees, this is eastern cottonwood, but its relative, the aspens, have a petiole that's flat. So if you were to try to take that leaf and roll that petiole in your fingers, it would not roll easily. It's flat. Think of a noodle instead of spaghetti. And so that's very unique for this genus. Think about the aspen that's pretty common all across North America that has leaves that move a lot. It's called quaking or trembling aspen. The reason it trembles is because that petiole is not very stout and strong, so it doesn't take much wind at all to make them move. Just other things to look for when we're out there. Stephanie mentioned compound and pinnately compound leaves, and you think of pinnate and pinna as feather-like. These really do kind of look like big old feathers. But then we start looking for other clues like these nuts that occur. This is actually our black walnut, very common species, especially in low-lying areas in Ohio and in good soils. And then there's tons of other characteristics. I look at leaf ID as tree ID 101, and the deeper we get into this, then we start having to rely on other characteristics. And so some of those other characteristics that you're going to learn over time are things like bark. Bark is probably the hardest thing to learn because it's a visual thing. There's no way to key it out easily. There are keys that show bark pictures, but bark is not always consistent. It may vary on how fast the tree's growing or how moist the site is. But bark is a great characteristic. My best recommendation for bark is that whenever you identify a tree, just look at the bark. And you'll eventually learn just by association. Buds are probably one of the best characteristics. They're there most of the year. Right now is the toughest time to identify trees by buds because the new buds have not formed. The old buds have broken, the new growth has come out, and the old buds have not, the new buds have not formed. So buds are great about 10 months of the year, but right now it's a little tough. But they're there in the winter and they're there even with leaf on. So as you identify trees later in the growing season, start paying attention to buds as well. Leaf scar is just that mirror image of the base of the leaf. And so there's some clues that we can use there. Pith is the center of the twig. If we cut into a twig, not many species we have to do that to identify, but sometimes it's a good way to confirm what we're thinking. There's multiple kinds of piths or centers of twigs that we can look at. Fruit and flowers, great when they're there, but they're there for a short period of time typically. So again, you can't always rely on them. Thorns are present on a few species, and the type of thorn and where it appears on the twig can all be great. The tree form, just what it looks like. Does it have a nice central straight stem? Does it have heavy branching? What are the branch angles? There's lots of clues there. And then finally, where's it growing? Is it in a wet area? Is it on a dry site? It's not 100% diagnostic, but usually trees have places they tend to appear. If you're in a swamp, you're probably not going to get a really dry site oak like scarlet oak. You're more likely to have a pin oak. So when you start learning where they grow, that's a good indicator when it comes to tree identification. So with that, we're going to wrap things up. Want to thank Stephanie, but I also want to remind folks that on June 12th, on Friday at 10 a.m., we're actually going to do a live presentation on how to use this key, which you'll see pictured. We'll also give you a link to that key so you can download it. The key will be available for purchase through OSU, and we'll share that information as well. I prefer to have it in hand and take it with me to the field. So the registration site will be here. And then we're also working hard to create a series of tree shorts or short video clips for a variety of trees. And it's going to take us a while. It might be a year or more before we get them all done. But eventually we will have a library of places you can go. You can look at a 2-minute video that kind of summarizes all the characteristics of that tree. Right now, we've got about 15 in the works, and we hope to have more available soon. So with that, if you have questions, you are welcome to call or email me. I also will keep folks posted and up to date on this website for Southeast Ohio Woods, which is where we post everything from A Day in the Woods. And I'd like to finish up by thanking Stephanie for joining us. Hopefully you learned a little bit. Sorry, I stepped over you there, Stephanie.
Nope, thanks for having me, and look forward to seeing everybody on our live session. Bring any questions you have to that as well. We'll try to get to as many as we can.
Okay. Thanks, everybody. Have a great day and be safe.